Hi, I'm with Industrial Solutions and Innovation, and I'm very excited to introduce today our Ready-to-Weld-3 MIG automated pipe welding rollout station. What we've got here is a dual bay 3 to 36 inch system. This can come in a 3 to 36, a 1 to 16, or a 6 to 48 inch configuration. The system we're going to show you today is a 3 to 36 inch configuration. We're using an EWM Phoenix 452 power supply that is water cooled. The power supply gives us up to 450 amps of continuous duty cycle, and we have dual wire feeders on this. So if you wanted to have a torch for hard wire and then say another torch for metal core or another torch for flux core, that is an option that you can utilize as well. Or you could have a manual torch on here as well if that was what you wanted. Our electrical cabinet sits in the back here. It's mounted to the floor. We have 20 feet of track, but that 20 foot of track can be longer or shorter depending on your need. This system has height elevation adjustment for the center line. So if you were welding pipe that you were going to have a T on it and you had a branch that was running off that was, say, 3 foot in length, we can adjust this center line so that you can swing that long branch pipe. All you have to do is pull these pins that are in there as a safety, and then JJ, my welder, is going to raise and lower this center line just to kind of show you how that works. We have that controlled by a Acme ball screw thread. And then once he gets that set to where he wants, he'll just drop that back into place, and we put the pins back into location. Bump it up a little bit, JJ. There you go. Okay, our safety pins are back in location. So now JJ is going to come around, and all of the welding parameters are controlled by this HMI. This HMI gives him full control over wire feed, rotation, all the parameters of the weld. And for this particular weld, we're going to be using two waveforms. The first one's going to be the root pass. The root pass will be done in what EWM calls root arc. We will then switch to what EWM has labeled force arc, which is more of a spray mode with pulse, so that we can have a two-pass weld, the root pass, and we'll do a fill cap to follow up. JJ, are you ready?
We're ready to go.
Let's go. The joint geometry here was a 37.5 degree V-bevel with a little bit of a land. We left an 1/8 inch root opening. We're currently welding at about 5 inches of travel speed per minute, and we're running about 270 inches a minute of wire. You can see the root pass going in. We're getting reinforcement. It's a nice consistent root. Now, as I said earlier, this system is a dual bay. So after we finish this weld, we're going to unlock the column and boom, and we will rotate 180 degrees, and we're going to weld another joint just like this. See, we're on that tack on the inside. We're reconsuming that tack, and now we're coming off the edge of that tack, getting a good tie-in. tack on attack there, as you can see. Coming off that tack, gonna get really good tie-in, really good sidewall fusion. JJ sees something in the middle of this weld that he doesn't like. We built in override so that he can adjust that on the fly. Obviously in this system, it's in a Windows-based system, so you can set percentages of override to make sure that you're staying within the parameters of your WTS or DQR. Coming into another tack here, consuming the toe of that tack, getting good tie-in. Coming off that tack with really good fusion, getting good penetration coming down. So our parameters on here that we're controlling, we've got oscillation width, we've got dwell time on both the in dwell and the out dwell, and we also can adjust for our slew or excursion time. We're running a 90-10 gas on this. You can run 75-25, you can run a straight CO2 on the root pass if you wanted to, but we find that 90-10 is a nice flexible gas, lets us do the root pass and then go right into the filling gas. So there's our tie-in, our root is completed. So normally I know that in production you would clean between passes here. We're not going to do that for the sake of just time on this video. But what we're going to do now is we'll transfer to the second pass. Jog over a little bit. Now again, what we're going to be using on this is what EWM calls force arc. We'll be doing force arc with pulse. So it will give us a fill and cap. We'll be above flush with reinforcement. And we'll be finished in 2 passes on this. Just verifying its numbers. I think we're ready to go. You can hear the difference there. Again, this is a force arc process. It's more of a spray mode, but we're doing it in pulse as well. We are running 330 inches a minute of wire feed. And we're monitoring our arc gap. So we sense that through the torch. So if we're welding on out of round pipe, we don't have to worry about keeping a consistent arc gap. We're monitoring that electronically so that the torch automatically rides with that ovality. We're traveling right now at about 10 inches a minute. traveling again about 5 inches a minute, so that's on an 8-inch schedule 40 like this. We're between 5 and 6 minutes on the root, and we're about 3 minutes to 4 minutes on the fill cap pass. So that's going to give you roughly 1 minute, per inch of OD. About to come into our tie-in. You'll hear the system kick up a little bit for the tie-in. The oscillation will stop. We have an overlap programmed in just a couple of seconds. And we're tied in. So that is a root to cap 8-inch schedule 40 weld. What we're going to do now is we're going to unlock the column and we're going to rotate 180 degrees so that we can then do the other weld on the parallel position. So now we've repositioned for this other weld that we're going to be doing. Again, we have 2 headstocks running parallel. So the idea would be you'd have one joint over here being welded while a helper or other workers are loading and unloading the parallel headstock. This will give you a much more efficient use of time and hopefully get you in that 80 to 90% arc efficiency rating that we're looking for. So what we have here, these pipe coupons are simply 8-inch schedule 40, and you'll notice these are machine bevels because of what we're doing today. And you may be wondering, do I have to have machine preps and perfect fits? The idea behind this system is that it can work in your environment. So if you were using a Watts or a Mueller pipe profiler and doing good, clean, square plasma or oxy-fuel cuts, those preps will be fine. Typically what you would do is clean inside and outside. You might kiss a little land on the face of it, and then we're going to do just an 1/8-inch root opening just like you would do for any other standard prep. So we're not asking for anything unique on that, but we will tell you that good tacks are something that we want because we're going to reconsume that tack. So if it's a bad tack when you put it in, it's still going to be there when we get done with the weld. So JJ is set up now for this weld. We're going to do the exact same program again. So he's going to be doing root arc on the root, and then we're going to switch to force arc on the fill cap. Again, it's a 2-pass weld for 8-inch schedule 40. JJ, are you ready?
I'm ready.
Let's go. You can see on the inside we're getting good root penetration. Tying in well to those sidewalls. Again, we're using a 90-10 gas. The options that you could go with, you could go with the 75-25. You could go with a straight CO2 for the root. But we find that 90-10 is forgivable, and it is a very forgiving gas, so let's just use it all the way out. JJ, how fast are we rotating?
We're about 5 inches a minute on our rotation.
So again, same numbers we used on the previous weld. Get ready to come into a tack, and you'll see there how we want to consume the edge of that tack, get a really good solid tie-in. Coming over the top of that tack now. And a really good tie-in coming off the tack. So JJ, if he wants to make adjustments while he's welding, that's not a problem. Another option for this would be a welding camera, which we would highly recommend. We typically use a Virus camera. We can actually tie the vision section of that into our HMI so that you're going to see that from the operator perspective. In fact, what we're going to do is I'm going to come around here to the HMI and let you take a look at that. So this is the operator interface right here. JJ's steering a little bit right now. We've got travel speed at 5 inches a minute, wire feed speed at 255. Here's our oscillation, both in dwell and out dwell, and our slew time, oscillation width. We have a correction factor built in. We're monitoring that arc length electronically, so if our pipe's not round and no pipe is round, we're automatically adjusting for that ovality. And what we have here is it says we're running past 1, we're going to end at past 1. We know that you're going to want to clean between passes, so we set it up to where it breaks the arc after pass 1. We can look at the root, make sure it's what we wanted to see, and then go into the fill cap. We go into the operations screen. This tells us how close we are to being finished with that pass. And here's our heat input. We're actually going to give you your heat input so we can make sure we're staying within your parameters that you set up in your WPS. Getting very close to finishing this root pass. There, we've tied in and we've finished that root pass. Okay, so while JJ gets set up for this second pass, we're going to step over here and want to show you a few things about our headstock. If you'll notice, we've taken the cover off this so we can show you how we do things. We have 2 Acme screws here that are linked together with this chain. We have 1 motor and gearbox down below. So this gives us the ability to lift a substantial amount of weight, be very rigid, but at the same time have something that's very simple to maintain and easy to repair in case something does happen. This is obviously going to be covered so that from a safety perspective you don't have any moving parts there that are available for a pinch hazard or something to that effect. We have a gripper that is adjustable. Again, this one is 3 to 36 inch, but if you want to go to the larger version, it looks very similar to this. We have 2 motors on the elevation, a little bit larger motor on the rotation, and we can go to a 48-inch gripper on that. The controls for the height elevation are on the back side of the headstock. While someone's welding on this headstock over here to my right, a helper can be loading and unloading, and there is a foot pedal that can allow them to rotate this while they're welding on the other one, so that you have full access and have a very high arc efficiency. So now we'll step back over there and we'll put in that fill and cap pass. So I'm going to have the camera swing around here and they can see the HMI that JJ is using, and we can talk through the parameters here. So again, on this we have our oscillation width, our slew time, our dwell time, our feed rate. Notice we're going to be at 330 inches a minute on feed. rotations at 10 inches a minute. We're monitoring our arc gap at 230. All of those are variables that the operator can control and manipulate while he's welding if he needs to make a change. JJ, are you ready for this?
We're ready.
Okay, let's go ahead and put on that fill cap. Again, this is going to be the EWM force arc using pulse. Just adjusting a couple inches. On its own. And that's all there is to it. It's a 2-pass weld, root to cap on schedule 40. We are roughly at about 1 minute per inch of OD. 8-inch pipe being 8.625 in OD. We are going to run out 9 minutes of arc time on this weld.